Okay, we're in section 24 of the notes. And again, my suggestion again is if you're thinking about moving into a STEM-related career, try to learn what's known as a computer algebra system. This is going to be the bridge, from what we're doing by hand to things that we can't do by hand. All right. But you need to know how to do things by hand first. So then when you get the problems you can't do by hand, at least you know what needs to be done. All right. And that's when the heavy lifting occurs and a machine is going to take over that role that you're doing with your hand at this point. So let's look at the code first, and then I'll go to the Sage. Remember, you can do Sage online if you like. That's with the CoCalc interactive worksheet. I've got Sage installed on my computer, so I would prefer to run it on my computer. All right. So let's take a look at the code. Reset. We've been doing this for a very long time. You know what? I'll open a terminal and I'll type this in. So what does reset do? It gives me a nice clean sheet of paper, so to speak. It clears out all the nonsense that Sage might have stored. X is dividing a variable. And in Sage, you don't have to define X as a variable because it's a default variable. But nonetheless, I like to do it. Okay. Next, I'm going to define a function, f of x. And that function I'm going to assign to it 7x squared. Whoops, I got to do times, right? Let's see, plus 4x. I got to do star again. I can't remember. Plus 6. All right, next thing I'm going to do is I'm going to say m. M is the slope of the secant line through the points f of 11. Doing slope now. It's a secant line minus f of 6. That's the delta f, by the way, divided by 11 minus 6. That's the change in x. All right, let me display m. M is the number 123. All right, so what am I saying? Well, we know what 7x squared plus 4x plus 6 is. It's the parabola. And what I'm saying, there's a secant line through the point, 11, f of 11, and 6, f of 6. All right, there's a secant through that. And what I'm claiming over here is I can compute the slope of that secant line. The other claim we're making is that we can find a point along f that's between 6 and 11 that has the identical slope, the tangent that is, slope of the tangent line. So I'm going to do that. So I'm going to say df, we're talking derivative now, is a function of x, and that function is equal to the derivative, that's diff, of f of x with respect to x. Now that's a fairly easy derivative to come up with, and we've done these problems certainly. We've actually done this by hand. It's a simple one. Let me just display the derivative df. That's what it looks like. And that's not a surprise for me. And that's 14x. It's very simple to do. What are we doing now? We're going to solve, find out where the point is along the curve that shares the same slope as the secant. When I say the same slope, the tangent line slope. So what are we going to do? df of x. When does it equal m? And again, we're solving for x. 17s. I'm going to draw a picture of this, and I'm going to use different software now. Now, someone says, why do you use different? Why don't you just continue to use Sage? As you move along in your careers, you want to have more than one tool at your disposal. All right, more than one tool. I'm going to say the more tools you have, the better. Like if you can program in multiple languages, it's better than programming in one language. All right, so what I'm going to graph, 7x squared, all right, plus 4x, whoops, plus, I keep doing it, don't I? Plus 4x plus 6. And someone said, oh, I don't see it, nor do I. So I'm going to just zoom out. And now I'm starting to see it. You see that? And I'm going to zoom in now. I'm going to draw, a window around this. And someone says, what's the window going to be? Well, I want to stick between 6 and 11. So I'm going to, I'm looking at it, and I'm going to say it's I'm certainly going to go much below that, but maybe somewhere over here. So what's 11? Well, if this is 25 over here, this would be about 11 up there. And let me see if I did a good job. All right. And I'm noticing 11's over here, but I don't see the graph. So I'm going to zoom out again. And I see 11 over here, but it goes up quite a bit. All right. So what am I going to do? Well, I'm going to kind of scroll down a little bit. I'm going to push this down. I'm going to grab it. And I want to go between 6 and 11. And I hope you know what I'm doing over here. I'm looking at the bottom curve. Bottom scale. And I'm looking for the 6. 6 is over here, right? All right. 6 is over here. I'm seeing that, but I'm not seeing the 11 yet. So I'm going to keep zooming out. I know it's tough. We'll keep doing that. All right. It's a lot of work though, right? I hope you realize that whatever I draw, I'm going to zoom in again now. This portion of the curve here. And I'm going to push up. And let me do 6. And 11. I'm still not seeing 11. I'm going to zoom out. So I'm seeing the 6. It's right over here. And I'm seeing the 11. And again, when I say 11, let's see, 5. Yeah, I'm going to change that scale a little bit. It's because it's too much work. I can't take all that work. Again, I want to say this a lot to you, that you want to find something that you enjoy doing. And if you're in a major that you don't enjoy doing, you probably want to think about what the other options are to you. And there's a lot of great options out there. I don't think there's only one option for you. Like, oh, it's got to be STEM. It's got to be STEM. That's not true. You got to find something that you're engaged in and that you're interested in doing. All right. So let me change my coordinate system a little bit, the layout. Let me see, axis and grid. And I'm going to go through, I'm going to change my abscissa. And I want to change it so the scale is 1 and there's no tick marks. All right. So let me point out what I just did. Change this thing so it's all nice numbers. So 6 and 11. I'm still not seeing 11. Let's zoom out again. All right. Between 6 and 11. I'm going to do another box around it. I know this is annoying. We're trying to get you guys to think, right? So I'm going to go here over to 11. All right. I'm seeing it. I'm seeing a point here. And I'm seeing a point over here. Now someone says, what's the slope there? Now, if you looked at it, you didn't have scale. I want to point out the run between 6 and 11 is, if you looked at that, that's 5 units. But a lot of people look at this and they start counting here and they say, oh, Joe, I can get the slope there. You're not looking at the scale. Right? Whoops, sorry about that. You're not looking at the scale. And if you look at the scale over here, I want to point out it's on the edge. And these look like they're going up by, I'm going to pull it over a little bit. Let me just push this back a little bit. And it looks like it's going up by 50s, these big marks over here. And let me see if that's true. I'm going to go back to my Sage. I want to do f of 6. Oh, that's 282. So I really can't read the scale over there. I'm going to zoom out a little bit. And so there's really so much work to think about this. And yeah, we're saying it is. But it's thinking you want to be able to do. All right, I'm seeing it better now. So what did I say? I said f of 6 was 282. Well, let's take a look at that. F of 6, yeah, about right, about 300. I'm looking at my scale, that'd be 300 there. And I'm going to say f of 11. Let me pull up so you can see it, by the way, is 897. Let me do that. I said about 900, right? Yeah, it does. It looks about 900, right? Now, there's a tangent line through there, those 2 points, by the way, and that's called a secant. I'm sorry, there's a secant line through those 2 points, and I compute the slope for that. And again, you can ballpark the slope against the picture, but we did that. What am I doing now? I'm saying there's a point along that, which is 17 halves. What's 17 halves? Well, 2 goes into 17. Again, I want to point out, I'm looking at this over here. That would be 8.5 times, right? So what I'm saying, at 8.5, there's a tangent line here that would have an identical slope to the secant line that went through 6 and 11 along that curve. All right, same thing, same exact thing. All right, and that's all we did over here. What theorem is that? Well, you may want to go back over your notes and review that. So I'm going to say, what was that? Well, we did Rahl's theorem. That's the mean value theorem, right? Let's go back over that. I'm going to search that for you. Mean value. I'll see if I can find it. Theorem. Let me see if I got this. You know what? I'm going to go back to my index. See, for some reason, let me put quote marks on that. Oh, right there. I'm sorry. I should have put quote marks on it. So what is mean value theorem? Let me just read it back to you. And again, this is part of your review process. It says let F function satisfy the following two conditions. The hypothesis F is continuous. The problem is continuous everywhere. It's certainly continuous, the problem that we've given you between 6 and 11. It was differentiable. Yeah, we took a derivative. It's derivative everywhere, but it's differentiable on the open interval AB. What do they say? There's a number C, and that's what we did with SAGE, where the derivative evaluated C, where C is contained on the open interval between A and B, such that the slope of the secant line is going to be identical. And that's all we did. This is part of your learning curve, though, to go back and realize that this SAGE stuff applies to problems that we've already done before or that you should have done before. All right. All right. Thank you.